So in traffic, in medicine, we know that in robotics, in finance, health, even in space. I know a project, for example, that uses AI to find the black matter. And of course, black matter is something which you don't see, you don't find, but you can use data or missing of data to build up theories. So there are a lot of success stories related to AI. There are, of course, the things which did not went so well with AI. We remember for 2018 accident with Uber when the system did not recognize the pedestrian or the bicycle and did not react properly. There are also other types of problems or failures, and maybe you have also heard about the program, AI-based program, which Amazon used for recruitment of people. And after a while, they realized that this system is gender biased. It would always recommend men candidates as better candidates, and after a while they realized that actually this was the result of the data they have been used, because in these companies most of people which are working are men, and then using examples like the best successful people in the companies according to of course probability would be men. So this is a typical example of biased prediction or conclusion or decision. I personally was very happy about one prediction which was completely wrong, and it's related also to Russia, and that was about the World Cup in 2018, which completely wrongly predicted who will play in the finals, for example. So we know about a lot of problems. There are a lot of discussions related to AI. But here I would like to ask another type of question, and that is what are the challenges or the problems in developing such systems? Will companies which are using AI be able to manage the complexity of AI development? You know, when using like AI in systems, you come with a new type of questions. Some of them are very important. They are not of technical character, but are still very important. Like, for example, who is owner of the data? What are the ethical aspects of using data? What can we allow a machine to decide? How to interpret the results from AI systems, models, and similar. And then we also have a number of technical nature data challenges which are related to developing and maintaining such systems. And it's not only related to programming. It starts much earlier, like how to efficiently collect, store, process, analyze, present data used for AI or for machine learning. How to efficiently build AI-based systems. How to ensure enough resources for the computation during the development and during the execution of the system. And how to ensure trustworthiness of such systems. So there are many questions which are related to software engineering. And then we can ask the question, okay, what kind of support do we have from the software engineering, and what kind of new support is required? So I would like to mention some of these challenges, to describe them and their nature, and starting from not from the life cycle of the system, but from a machine learning workflow. So the process in which you build up your model, and which consists of like two loops, you can say. You start with assembling the data, which will be used for building up your model. You create your model, and then you try and evaluate, and you are in this inner circle. And then you can deploy a model when you achieve accuracy or some other parameters which are which satisfy the requirements. And then you have this outer loop, which is like a sample of new data and redeploy. And this is typical workflow which data scientists are working with. But if you look at the entire life cycle, then you can see this small black square. This is this part which I mentioned before, and the rest is you must have in the place to get a successful development and production of AI-based systems. From the data collection, configuration of the systems and collecting data, which type of data, selecting which characteristics from data you will use for machine learning, like this feature extraction, ensure machine resource and management using different tool analysis, because manually it's almost impossible to use that, and so on and so on. So this is a paper from several years ago which describes what kind of challenges company meet when developing such systems. And what is the basic problem from the software engineering point of view? The basic problem is that this approach is against many principles which we are using in software engineering. You know, like typical principles are related to separation of the concerns, information hiding, abstraction, typically implemented in component-based software engineering, in which you have a component or object in which you have an encapsulated functionality and very well defined interfaces, input and output, so that you can predict the changes, predict the functionalities, but also the changes which can happen in the system. And this is done quite well and quite controlled. But now we are using data which are used for machine learning, for building up the code. And it's a question, the basic question is what kind of control we have of that. And just because of that, we have introduced data, you know, in our algorithms. Suddenly we get new challenges. Here, I just have a short list of these challenges, some of the examples related to entanglement or data fusion, then data dependencies, hidden feedback loops, undeclared consumers, correction cascades. These are some examples, and I will just mention some of them that you'll get a feeling about that. And the first one about data fusion, or using different type of data or different type of features, so you know which you're using for learning. And what is happening? Of course, by changing data type or changing these features, the models are changing, on which we don't have influence. But then we have additional problems. If we, in our evolution of software, and we know that software is by nature evolving all the time. So in this sense, we want also to include new features in our evolution of software. And then we can ask what kind of changes will happen. And what is characteristic here, that change anything can change everything. So a small change in the feature or adding a new feature can give completely different results of models. And that has a consequence that usually, like building up the models, like first version of AI system is easy to obtain. But then when you come to the evolution and maintenance part, then it makes a lot of problems and unexpectedly difficulties. One of them is related to data dependencies. We know in code dependencies, it's typically known as technical debt. So if we don't separate these dependencies as code, we can have problems, but very often we are using it in fast programming. But with data dependencies, the things are much more complex. Across data change over time, like value, accuracy, precision. And since our modules are changed, or we get better prediction if we do retraining of using new data, it is obviously that we need to have control of this change. If you want to have a control of change of the models, for example, we want to go back to a particular model, then normally we would need to know which data sets we have used. And today there is no real support for version and configuration management of data. And there is no support of version management and configuration management of code and data together. So this is one of the challenge which can introduce a lot of troubles when we want to reuse code and data, or when we want to run different variants or evolve system. The other thing, or also what can happen related to that is, for example, using or getting unwanted hidden feedback loops. In many cases, we are using AI components which are using data, but also which are using generating data. And even this component can be in the process of a chain when generating data, which then back is used in these models. And then the system itself can be trained in that way that it's actually optimized this loop for data, so to generate the best data which would fit the best to the model, not actually to the real problem. And this is one of the typical problems which can occur. And similar to that is that if we have like a cascade of the components, and if we have consumers of particular AI-based components, but which we don't know, and we change our model, or even just change our data set, that the new AI components which are using this first component model and maybe common data suddenly is not compatible, and this compatibility we are not aware of. And that can cause to faults if in the component C2, if not less optimized performance. Okay, so that, and then when you look at the code itself, when building like applications which are AI-based, then of course you think you have this advantage by building up AI models which are kind of semi-automatically built up from data sets. But when you look at the code which are using AI models, then there is empirical evidence that it's about 95% of code is a glue code. And it's based on reformatting data, adjusting the data, so you come to this pipeline jungles of communication between components. And of course, such if you have 95% of code which is used as a glue code, that you will have a lot of you will need a lot of efforts to maintain such a code. So today, code which is using AI is in general bad code, and in general is not following basic software engineering principles which we have built up in many years. Also, like typical example, when performing this training with different data sets and different models, you will come with a lot of versions, but also a lot of versions of the code. And by programming, you will come in a situation that you have a lot of dead code, for example, which you have used in previous version, experimental version, but not used in the current version, and which again cause difficulties in the maintenance. And finally, one typical problem is when you train a system, you know you are using a set of data which you obtained in some way. You get trained in the system, and then you are using the system. And when you are performing the system, you are using new data for example, recognizes objects and so on. But then if this new data is different, if it's in a different context, if your system is not aware of that, you can get very unpredictable results. And that means that you must have another means to checking that. You know, if you are not sure about accuracy of your system, you have to monitor your system all the time. And that, of course, increases a lot of additional requirements on computational resources, also requirements on timing, latency, and different type, which you may don't think about when you are developing one AI component with particular function. Usually it happens like that you might think that focus in AI development is related to that create models and train, evaluate your system. The actual amount of effort is quite different. So assemble data, managing data takes much more efforts and problems, and the same is with the deployment. And many companies today are not aware. Many companies are still in this first phase, and they are now facing challenges of collecting data. They still not come to the challenges of maintenance and evolution of the systems. So there is a risk that many companies will fail in their introduction of AI systems. I have just some examples. We did some empirical investigation about what are the main challenges seen from different companies. So these are results from some 10 different companies from different areas, business areas, using AI. And then you can see, for example, effort estimation. It's very difficult to solve today. The same, it's a big problem with managing blue code. If you look at the operational product challenges is related to troubleshooting, but still less problematical to solve. And if we come to the organizational challenges, dependency management is between data, but also in organizational aspects, looking, for example, cultural differences, there are very big problem. There are big differences between data scientists and software engineers in perception. Okay, what is the most important, and how much effort you need to put in the system, and what is the quality of the system. So by that, let me present this, that when we are talking about AI development, or actually we have to think about more, and we can call that AI engineering or software engineering for AI. In this circle in the middle, you can see the things which are related to the data science, AI data science, and all around you have this AI engineering, so managing data and code. And then in addition, you have a lot of activities you have to think about, which is related to particular domains, which are known as before, but now you have to use new methods which must be developed. Okay, and maybe coming back to OSS, open source community. So what open source community can do about this? And I have found two things here. There are a lot of platforms and frameworks under development, and that's very good, which are addressing these questions. And here you can see some of them, which are used in OSS and in general community. Some of them also in industry. What is more missing is related to data. Although there have been a lot of discussions about how to collect data, about big data, how to make open source of data, it is not only a question about having available data, but it is a question how to manage this data. And there is one paper which addresses these questions, which says about a need to build up something similar to OSS, like open collaborative data, which can call like that, which should have like similar concerns, technical infrastructure, in which the things which are related to data should be addressed. Version configuration management, data dependencies, data semantics, for example, because this semantics is quite dependent on the context. But then specifically data license models, who is the owner, who can use and which way, related to data privacy concerns, and in general data governance. So from our researchers' point of view, it's like exciting. There is like great time because there are a lot of things to do. And of course, we are optimists, and I think it's possible to manage this. So this was a short overview. So thank you from my side.
Okay, so Professor Crnkovic, thank you for this talk. And now let's go to questions, to question sessions. And first of all, I would like to ask my personal question about this machine learning systems and the implementation in industry. So, as far as I know, one of the main issue for now is the problem of non-determinism of such systems. And is it possible somehow, like, are there any research in this direction, like up-to-date researches, which give us a chance to overcome this problem?
Yes, yes. You know, you can say that they can be maybe two basic different approaches. One approach is related to pure AI methodologies. For example, related to explainable AI or trustworthy AI, in the sense that the result you get is in some way both explainable and certain probability of different properties. So AI itself comes with a number of properties like accuracy and so, which are the result of the training. But the main question is, okay, what happens actually in the system? And to that is related, of course, this explainability in a sense. If you change something, how that will affect your AI model, both in the sense of changing of data or changing of parameters. So there is a lot of research about that. The other approach is like from the system engineering. You know, we have some uncertainty which methods you need to use to have control of these uncertainties. And in that sense, similar principles as the classical principles are applied, like looking at robustness or resilience, for example, ability of the system to accommodate to the different changes. So there are then solution on architecture and on the system level. But there are, of course, many open questions, and I know we have a cooperation with many companies in Sweden, high technology companies, which are using AI, and they are really starting to face this problem. Okay, how they can guarantee particular quality of such system. It's not only about predicting, but it's also about other properties, like, for example, performance or latency, real time.
Okay. Well, thank you. So we have time for maybe one or a couple of questions from the chat. So what software development process can be proposed to data analytic teams? What you can suggest for them?
Yeah, you know that there are some research and some known in some literature, but it's still not established. The processes, people talking about, if you have DevOps, how to integrate this DevOps with machine learning and called ML ops, or you have like data ops, in which you integrate those activities which are coming from machine learning with the development processes. So there are some papers, for example, from Microsoft and from Google, which describes like this life cycle and which processes you can use. I would say this is still a widely open area. And certainly in a few next years, this will be like one of the main topics in software engineering community, but then probably in a few years, some methods will be established.
Oh, we have much more questions now. So, what do you think about ML flow and other machine learning pipeline tracking tools?
Yeah, you know that there, of course, you have now different tools and different frameworks, and even now coming some tools which provide the entire framework, for example, using configuration management, and a lot of companies. So I would not now list them or talk about them. It's too much time, but I can provide some information later. Okay, I don't hear you now.
Sorry, is it better now?
Yeah, now it's okay. Yes.
Okay, good. So thank you for your presentation. We have more questions, but we have no actually time. We're running out of time. Thank you for joining us. Thank you for giving us such interesting insight in machine learning topic, machine learning area. And now I would like to present our next speaker, who is Professor Manuel Mazzara, Professor of Innopolis University, with a speech titled Software Release Anomaly Detection in DevOps Environment. So, Professor Mazzara.
Okay, I'm here. So you can hear me?
Yes, pretty good.
Maybe you can see me also. I think it works.
Yes.
Good. Okay, I'm here in Innopolis University. I don't use the background because I have some problem with the green screen here. So I will now share my screen, and you should be able to see. Correct?
Yes, everything is good.
In this moment, you're seeing looking at my screen. And thank you very much for the invitation. And this is a nice experience to have such a large conference online for the first time in Innopolis. Hope there will be more, but this is, you are sort of pioneer, okay, of this conference. I wanted to present, today I will present one of our research topics. I mean, we have several projects ongoing in cooperation with Innopolis University. This work was done also in cooperation with the Italian University, University of Messina in Sicily, that I want to say hello to them at the moment. And it's how to apply anomaly detection techniques in DevOps toolchain. My talk is organized in two parts. In the first part, it will be a little bit more generic. And in the second part, I will go into the specific of the research and of the application of the prototype and the proof of concept that we are deploying that is also available online.